Hello Miss Almiri and fellow students. Today I'll be going through two reactions, acid and base and precipitation reactions. These reactions are done by mixing chemicals to make a product. These materials can either be found in nature or made through mixing other minerals. There are many types of acid and base reactions. For example, acid and hydroxide and acid and carbonate. Acid and hydroxide make salt and water, and acid and carbonate make salt, water and carbon dioxide. Some examples of acid and hydroxide reactions are phosphoric acid and sodium hydroxide become sodium phosphate and water. Nitric acid and lithium hydroxide become lithium nitrate plus water. Some examples of acid and carbonate reactions are hydrogen chloride plus lithium carbonate becomes lithium chloride plus water plus carbon dioxide. Another reaction is sulfuric acid plus sodium carbonate becomes sodium sulfate plus water plus carbon dioxide. Now off to the experiment. Firstly, I'll be talking about the materials used. Materials used will be baking soda, white vinegar, the bottle and white vinegar with the baking soda and the balloon for carbon collection. These are the pH strips, and it has the pH scale at the back right here, and this is the strips. The orange one shows the pH, and these are all for pool and other stuff. Firstly, take one big spoon of baking soda and pour it into the white vinegar. As you can see, the foaming up and the bubbles is due to the mixing of the vinegar and baking soda. And carbon is made due to the mixing. Now to test the pH, we dip in the pH strip, wait for a bit, and pour it out. As you can see, it turned to a dark orange. It's slightly to mild acidity, and as you can see, it's a bit acidic. Now for the carbon collection, pouring, and as you can see, the foaming up is making carbon dioxide, which is inflating the balloon. Now that I have completed the experiment, I'm going to be talking about the essential uses of acid-base reactions. Acid-base reactions are essential in both biochemistry and the industrial chemistry. Moreover, many of the substances we encounter in our homes, the supermarket, and the pharmacy are acids or bases. For example, aspirin is an acid, acetylsalicylic acid, and antacids are bases. Vinegar or acetic acid has the chemical formula CH3COOH. Baking soda is the base, also known as sodium bicarbonate. During this reaction, the products are sodium acetate, which the chemical formula of it is C2H3NaO2. The other products are water and carbon dioxide. Now, a precipitation reaction. A precipitation reaction refers to the formation of an insoluble salt with two solubles containing soluble salts are combined. The insoluble salt that falls out of the solution is known as a precipitate. Precipitation reactions are useful in determining whether a certain element is present in a solution. Precipitation reactions are used to remove salts from water, isolate products, and to prepare for pigments. Under controlled conditions, precipitation reaction produces pure crystals of precipitate. In metallurgy, precipitation is used to strengthen alloy. Now I'll be showing you how to cross valencies, balance an equation, and see if it's soluble or insoluble. First off, crossing the valencies. As you can see here, sodium and phosphate have two different valencies, +1 and -3. All you have to do is put the -3 down here next to the A and the +1 near the 4. So this means it will be Na3, as you can see, Na3 and PO4, and that's it. Now on the same side here, for aluminium and nitrate. Aluminium's valency is +3 and nitrate is -1. All you have to do is drag it down, the 3 down here, and the -1 down here. They become aluminium 1 and NO3 3 bracket 3 to see if it's soluble. Using this chemical equation here, Na3 sodium phosphate plus aluminium nitrate becomes Na, and nitrate becomes sodium nitrate and aluminium phosphate. If we use the valency table right here, as you can see, phosphate is soluble for lithium sodium, potassium, and other things. And the rest is low solubility. As you can see here, Na3 and PO4, as we mentioned before, phosphate is soluble with sodium, so this is aqueous. Aluminium and nitrate is soluble with every mineral, so it's aqueous. Same here again, nitrate is aqueous with the other mineral, and here aluminium phosphate is different. Aluminium is not part of the low solubility, and it's actually low solubility, so it becomes an insoluble. So this chemical reaction becomes a precipitate. Now to balancing the equation. Here we have Na3, sodium 3, phosphate 1, aluminium, nitrate 3 over 3, and here after do that on this side will be Na3, Na and nitrate 1 and aluminium and phosphate. As you can see here, we have three sodiums here, 1 aluminium here, 1 phosphate here, and 3 nitrates here. On this side here, we have one sodium, 1 nitrate, 1 aluminium, and 1 phosphate. All we have to do is multiply to get the same answer as this. So do 1 times 3, and that makes sodium and nitrate, you multiply them by 3, and that makes sodium and nitrate 3. So what you have to do in this equation right here, as you can see, you add a 3 at the start, and it becomes 3 Na and NO3. So when you expand this, it will be sodium 3 and nitrate 3 times 3.